Okay, so today we are learning how to find the volume of a cone. So if you didn't watch part one, go back and watch part one. It's a good example. All right, so a cone is a three-dimensional shape, has a circular base, and the sides come up to form a point at the top. All right, so like an ice cream cone, the cone cups we drink of at school. There's funnels, like a little party hat, something like that. So here we go. We have a cone. And so if it's a circular base, that means it has a radius, right, which is from the midpoint to the edge of the base. So that's the radius halfway across that circle. And then the height is from the point, and we're to meet straight down at that center point. The height, well, it actually has to form a right angle, right? So it needs to meet straight at a right angle. So if you had a point, like a cone that was tilted, the height is straight down, meets at a right angle. And maybe you'll notice that that's a little right triangle we got in there. Right, if you use the slant height and the radius and the height. But if you have a cone with the same radius and height of a cylinder, right, which is in the video, if you look at part one, right, that's that cone cup and the beaker, science beaker, they have the same radius, same size circular base, and they are the same height. Right, so they kind of fit inside each other. For example, so if you had a cylinder, this is just a little drawing. If you had a cylinder and with a circular bases, and you were to put a cone in there, right, and the cone's tip were the same height as the cylinder, this is what we're talking about. All right, then we might find out, if we took that cone cup, which is in the video, and you're going to fill it up 3 times. There are 3 cones worth of volume that will fit inside that cylinder. Okay, so, you can trust me, or you can watch the video and it would prove it, but basically 3 cones can fit inside one cylinder that's the same height and the same radius. So that means that we can just use the volume of a cylinder that you guys have already been working on. We're just going to modify that. Okay, so we're going to take that volume of a cylinder, and the volume of a cylinder is pi r squared times h. All right, so that's the volume of a cylinder. And we're just going to divide that by 3. All right, so the volume of a cone, right? So volume of a cylinder, pi r squared times h. Hopefully you've been practicing that. And so the volume of a cone is just the volume of the cylinder. So we're going to write that same thing, pi r squared times h. And we just take the volume of that and we can divide that by 3. So now that kind of looks like some math, but that's using that old-timey division symbol. We try to get away from that. So how else can we write that in 8th grade math or as you're going forward into high school, right? So the volume of a cone, we can write that as pi r squared times h, and then the whole thing divided by 3, right? The whole volume of that cylinder divided by 3. That's one way we could write that. Or, right, the volume of a cone, we can just write that instead of divided by 3, the same thing is done, like that's 1/3. You divide something by 3, it's in parts of 1/3, so we can take 1/3 times pi r squared times h, which is the most common way that you're going to see that formula written. So most commonly, you're going to see the volume of a cone is 1/3 pi r squared times h.